when we think about this lesson, as we are working, again, we're trying to kind of refresh our memory on our systems. And when we were working with systems, graphing them in our coordinate plane, kind of like when we started out with systems. So this is lesson 6.6 in your book. We did 6.5 earlier. So we're just trying to think, when do we use that dashed line? Abby, what do we know when we should use the dashed line?
That it's less than or greater than.
Less than or greater than. Okay? Anytime I have a less or greater, I know if I have y happens to be less than 4, that is going to be a horizontal line. And then, to kind of go with that, where do I know I'm shading if it would have been y less than 4 or 1?
The left side.
So in this case, if I have y is less than 4 and I have this horizontal line, would you go above it or below it for less than? Below it. So when we think about below, that's going to be for which inequalities? When we have a what?
Less than and less than.
Less than or less than. If it would have been y is less than negative x plus 1, right? Then I would have had that positive 1. I would have had the dotted line going like this. I would have shaded below that, right? All right, how do I know when I'm going to have a solid line then? What is that one already going to look like?
When the inequality is greater than or equal to or less than or equal to.
Right. When we have greater or equal or less or equal. So it could be either one of those. And if we think about x being greater or equal to 2, that would be a solid line. And where would I shade, Otto? X is greater or equal to 2. To the right of that, right? If I would have had y is greater or equal to x, right? I look at that equation, maybe I have x plus 2, which means up here, and then I'm going to have this solid line. And here I would have shaded above, right? So the above the line or to the right, that is for my greater or equal, okay? So just making sure you understand when you're shading and where you're shading. Okay, is that making sense to everyone? Kind of remembering that? So, our vocabulary, system of inequalities. It's made up of 2 or more linear inequalities. What do we have to watch for with linear inequalities when we solve for y? We don't have to do it in this one, but there's 3 homework questions that you have to watch out for. What do we have to do when we're solving for y? What do we have to really watch out for with inequalities? Anyone remember? Yeah. Dividing by a negative. This one, like I said, when you rewrite this inequality, and you want them both in slope-intercept form. So it says the system is 2 or more. The solution is any ordered pair. So keep in mind, it's going to be that xy is going to be our solution that makes it true to both. And we graph it, and when we do that, we look at the solutions and we shade. So the first one, you can see that they graph that. That is this red line, okay? This is the red line. Y is less than 2x minus 3. They started down at negative 3, had a slope of 2 over 1, graphed it, dashed line. The second one, before you can really graph it, you're going to want to rewrite it. And so this is kind of what the 11 to like 19 of your homework look like. You have to rewrite this to be y is greater than, and we have negative 2x plus 2. And that is this equation over here. It's still a dashed line, and we are looking at the greater than. Now, in the textbook, along with up here, and I know it might be really hard in your notes, but in your notes, would you shade this part a lot darker? Because this is the overlap, okay? And I think it's kind of hard to tell in our notes that this is the overlap. So just shade it a little darker. It says, the green region represents the solution of both. So we graphed the first one and we shaded below. And it's okay when you do your shading that you kind of do something like this and you just kind of shade below. And then the second one you're shading above, right? So we do something like this. And then what you want to do is the place where they overlap, you want to make that super dark. Because if I asked you, well, what's a solution to this problem? I can pick any number in this dark shaded region, the green region, and it's going to be a solution. Like 4, 0 is an easy solution, right? Right here, 4, 0. I could go with 4, 2, right? That's going to be a solution. I don't have to use integers. I could have 3.975, right? 3.975 is right here, and I could go down to a negative 1.723, right? That should make it true because I'm looking at like this number right here, right? So it can be integers, but it can be any other number. So what we are looking at is these two equations. And this is the green, so if on yours you need to shade this a little darker, this is where the solution is, okay? So if I am looking at that, that's where my solution is. So if I'm looking, this part down here is the super green that they're talking about. This one over here is where your solution is. Tanya, I'm going to write a solution for that blue line. Y is what? Because it's a solid line. And shaded below. Less than or equal to. Can you tell your slope? 1/2, and it's positive. So I'm going to have 1/2 x. And can you tell the y-intercept? 1 + 1. Ryan, I want to do the red equation next. The dotted line.
So one would be like y is
they're shading below.
would it be less than
slope.
a negative 1/2
Negative 1/2, nice work.
and then +1.
+1. So part of your homework, there's 2 questions I think in the homework like this where I give you the graphs and ask you to write it, okay? Then you have to graph like about 5 of them where I just give you the 2 equations like the first page. So right now I want you to try the second one. We're going to do an equation for your dashed line and the equation for the solid one. And then I just want you to check with the people behind. So Becca, the first one, what did you come up with?
Y is greater than or equal to x minus 1.
So we started down at -1 for our y-intercept, so we have a -1. And our slope is a positive 1/1, okay? So could you have 1x? You could, greater or equal, because they shaded the blue above, okay? Tanya, I want to go to the red equation.
Y is less than negative 1/2 x plus 5.
So we go to 2, 3, 4, 5 is our y-intercept. Down 1/2, down 1, yes. So we shaded below that. So that was down here in yellow. And then this was our final solution, okay? All of this, all of these points here are our answer. So you will be asked to give a solution when you look at that. So just make sure if you do shade, like if you shade this one kind of like this, and then you shade this one going down, that then when you do the overlap, you just shade that really darkly for your answer, okay? All right, so we want to graph these two because this is what it's going to look like for your first 3 homework questions. Not 5 or 7, maybe. So you're going to use graph paper. We want to graph the first one. My starting point for the first one, auto would be where? 5. Now you got to be kind of, this graph goes by 2, so you got to be careful. So it's +5, and then our slope is a -x. So if I'm going with a -x, or -1, that's down 1 and over 1, that's like here. It's always in the middle of each one, right? And it makes sense that I should have this point over here at 5, 0, right? Because if I'm looking at that, if x happens to be 5, y is 0. Samantha, solid or dashed line?
Solid.
Solid. Once I have my solid line, I now need to decide, Hannah, where should I shade, above or below? Above. So I'm just going to lightly kind of put a few lines so I know, yep, that's where my solution is. Next equation, Devin, I need to rewrite it in slope-intercept form. So when I do that rewrite, what are you going to have?
Y is less than or equal to negative 4 plus 3x.
And I'm going to put the 3x first so that I have my slope, and then I have that negative 4 back here. So that tells me I'm going to start down at negative 4. Abby, what is it telling me my slope is? 3 over 1. Now again, this is 2, so I got to go 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3. Solid or dashed line, Abby?
Solid.
Solid. Shading auto to the above or below? Where should I shade? Below it. So I'm just going to kind of do, and then I'm going to take and like make it really dark and know that this is my solution, right? And so that when I'm looking at that and you're doing your shading also, you just want to make sure that final solution is really dark so I can tell. There's some people, not so much in this class, but in the other one, that write so lightly that I can hardly even see their answer. So just make sure. So now it says, what is one possible solution? I actually want you to tell me at least 3. I want at least 3 possible solutions that are in your dark shaded region. So write at least 3. So if I call in you, you can tell me at least 3 that are solutions. Ryan, give me 1. 8 and 0. 8 and 0. Owen, give me another.
4, 2.
4, 2. Yes, right there. 4, 2. And one more, Sam.
5, 0.
5, 0. You don't have to make them hard when you're looking at those. And then the other thing is that if I plug these 2 numbers in for my x and my y, they would need to work up here, right? So if I put in 0 is negative 5 plus 5, yes, that works. If I put 5, 0 in here, negative 15 is definitely less or equal to negative 4. And if I do the same with each of these, they need to make both of these true, is what we are looking at, okay? All right, so then the story prompts. We're going to do this one. There's one very similar to it in your homework, and then there's another one that's really similar to the got it problem that we're going to do, that last example. So if you turn to that last page of your notes, you can see it then has what's going to be on the tests, because this is the end of our unit. So you're planning to do what to do after school. You can spend at most 6 hours daily playing basketball and doing homework. So they're thinking, you leave school at 3:30, so you got another 6 hours, right? So you got till 9 or 10 o'clock. That's what you're kind of thinking, right? 4 to 10, 6 hours, okay? You want to spend less than 2 hours playing basketball. Well, maybe you want to spend more, but you're limited. Your parents are going to say no. And you must spend an hour and a half on homework. What is the graph that shows this? So one of the key things that sometimes a lot of you seem to forget when you're doing, when you're working with equations is, and you make graphs, and especially the story problems, you forget to put your label. So definitely this is X, but this is my hours playing basketball, right? So when you identify the variables, X, that's your hours basketball and hours homework. Would it have mattered if you switched these 2 around at all? No. But whichever one you decide, then you want to make sure that if X is basketball and Y is homework, that you kind of label your graph. So it's always a bummer for me when I'm correcting the tests and we do something like this, and you graphed all of these lines great, and then you didn't label it. So I don't know what you're talking about, right? I don't know if this one is basketball and this one is homework or vice versa. So make sure you have these labels when you are doing your graphs today. It says x plus y, we can only up to 6 hours, so it's less or equal to 6. So they started at 6 here, and I also know my y-intercept, my x-intercept is going to be 6, and I can make that a solid line. I can have less than 2 hours of basketball, which means it's a dashed line. It's vertical, and I would have been shading everything to the left of that. So I can't have negative hours, so it doesn't go into, it's only going to be in the first quadrant, right? So I'm not going to have negatives. And then same with the hours of homework. I could have up to 6, right? That's my max, because I'm only going to have 6 hours after school to work, okay? So when I look at this, the minimum I can have is an hour and a half. Can I have all homework and no basketball? Is that possible? Can I have an hour and a half of homework and no basketball? Or 4 hours of homework and no basketball? Points right here, like this one and like here. I could, right? I could have up to 2 hours. I can't have 2, right? But I could have 1.75, right? Or like an hour and 55 minutes, right? And I could have 2 hours of homework, right? So it says, when we look at this, the solutions of the systems are all points in the shaded region, included the solid line. So we could have it on the line. I want you to give me possible solutions. And please know that when you do that, you should be able to tell me, in this case, because it's a story problem, you would say hours of basketball, right? Blank hours of homework. It does not make as much sense to give me an ordered pair for your answer, right? Because it's a story problem. And so they say, what is this graph showing you about your time? Well, the graph shows us that our time is spent here for our answer. So give me at least one answer that would work. Devin, what? How many hours basketball are you doing? 1 hour. Okay. So 1 hour. How much homework time? 3. 1 hour and 3, right? That works. That's this point right here. Because you have 1 and 2.45, yes. 1 and 4 hours. 1 and 2 hours. Exactly if we're looking at that, or 1 and a half. 1 and 1 and a half. Okay. Does that make sense to everyone when we look at those solutions? All right. One of the questions in your homework, I'm not sure if it's number 26 or 28, is just like this one. You're trying to build a fence that you want your dog to be able to run. You want the run to be at least 10 feet wide, and you want the run to be at least 50 feet long. And you have 126 feet of fence. So we want to have 3 inequalities, okay? When we look at that, 3 inequalities. As we look at our inequalities, okay, notice on your graph that the width is x. So when we think of that we want it to be at least 10 feet wide, what we're really talking about is x, which is our width. We want that to be what? Greater or equal, would you say, or lesser than equal to 10? We want it to be at least 10 feet. Owen, what do you think?
Greater equal.
Greater or equal to 10 feet. Can we graph that line right away? We can go to our graph here, and at 10, right? Greater or equal to 10. It's going to be everything over here. Marie, that next statement, that the fence must be at most 50 feet long. So my length is my variable y, right? So if at most 50, what do I want to do with the 50?
Y is less than or equal to 50.
less or equal to 50 feet. So we're going to do that one and we'll do that one. Yes. So looking at this one at 50, right? And at this point, I'm not even going to shade over here, right? Because it can't be in this area. I know because this one, so right now, it's here, right? I have one more that I need to graph. That's the last one. It says you have 126 feet of fencing. So if I think of a rectangular, my fenced rectangular that my dog can run, I said this is my width and this is my length. So what am I finding when I say I'm going to fence 126 feet of fencing? What is that, 126? That is the what? Going around that pen. What is that? What? Oh, perimeter. It's perimeter. It is not the area. It's the perimeter. You have 126 feet of fence. So when we think of doing perimeter, a lot of times I'll have students do this. They'll say that this is 2x, 2 times the width plus 2 times the length. And in this case, it has to be less or equal to 126, right? It could be equal to 126, but that's the most fencing we have. The other way to write perimeter is to think of it this way. 2 times x plus y is less than 126. Do you agree that those are the same equations? Okay. So when I look at those as being my same equations, to me, the second one is the one that I want to solve. And the reason I want to solve this second one is it's really easy to divide right away both sides by 2. And if I divide both sides by 2, remember, I want to get it in slope-intercept form. I have x plus y is going to be less or equal. 126 divided by 2 gives me 63. What form is this equation in without, if I'm just looking at this equation before I rewrite it? Standard form. In standard form, if x is 0, where is y going to be? If x is 0, this point is going to be at 63, right? What about if y is 0? Where's my x going to be? Over at 63, right? I had someone doing their graph and they started going, they rewrote their equation and said the equation was y is less or equal to negative x plus 63. And when they started doing the down one and over one, it came out way over here, like between 70 and 80. That's not precise, right? That's not good. If I plug in 0 for x or 0 for y, I get 63. So when I'm looking at this graph, I need that to go from 63 to 63. It's a solid line because it could be any of those points on there. And now my final solution is going to be anything in here. And I could erase these other areas because I know it can't be over here. Or I can just shade this really darkly, okay? So that I'm looking at that being my solution. What is the shape of that shaded region? Anyone know what that shape is? Almost a triangle, but not really, because this side here. Anyone know what that is when the sides are, you have a length here? It is a trapezoid. Because there's a question in your homework that says, like, what's the shape of the region, okay? If I was looking at the one before this, when we did this shaded region, this is also a trapezoid, right? If it would have been in here, it would have been a triangle, right? So there's some in your homework that ask you, like, what's the shape after you do the shaded region? So what are possible dimensions? And again, my hint if I was looking at this would be I might want to look at and put the width first. Why width first? Because that's my x. So I might say it could be 30 feet wide by 20 feet, right? Long. Please give me at least from the one I gave you, put down 2 more dimensions that I can call ideal. And you could tell me 2 more dimensions that are going to work for our dog. And usually most people, if they're really wanting their dog to run a lot, right, would go with the bigger ones. But if you have a shortage of fence, you might go with smaller dimensions, right? So, all right. Marie, what do you have?
45 feet wide by 15 feet long.
45 feet by 15. Yes. Abby, give me one more.
25 feet wide by 30 feet long.
So we're going at 25 up to 30. Okay, so that making sense to everyone as you think about those? Okay. So in your homework on page 403, we're doing 11 to 33, the odd. And 26, 28, 32 are the evens. I have both different kinds of graph paper. I don't know which kind you like, if you like the whole big paper or the ones that have the individuals. When you go to do your homework on the graph paper, I need the new equations, okay? So when you go to do number 11, why do you think I highlighted 11, 19, and 21? Why are those, just as you look at those questions, why do you think I highlighted them? What's going to be where people will run into some silly mistakes? We do have to change them, and where might, like the first one, everyone knew the problem. But when people do this second one, they will subtract 2x, and you then, when you subtract 2x, get negative y, right, is less or equal to negative 2x plus 4. When you divide this by the negative, the reason I did the highlight is a lot of people will forget to change the inequality. And my hint is, do the first one and graph it, and then when you go to the second one and you're getting ready to graph it, you're going to rewrite it and you're going to have y, and hopefully you change it to greater or equal because you're divided by negative 1, and you get 2x minus 4. Now what do you notice about those two equations when you look at them? What do you know about their slopes? What kind of lines do we have from our two equations? What kind of a line will I have because I look at their slopes? What do we know when the slopes are the same? So as you start thinking about this in your final approaches and like all this thing, what do we know when you look at two lines and they have the same slope? They are always I was looking for parallel, so if you're not sure about that and you go two slopes are the same and I don't know that it's parallel, you want to go back and make sure that stuff and slope intersect in equations. Because these two will be the exact same parallel lines. They just have different y-intercepts, right? And I want you to take a look in your homework. There's, in this question, number 28. So number 26, and I will tell you that 27 is a hard question. So try setting it up. We will definitely look at that. 27 gives people questions. So don't say tomorrow when you come in, hey, Mrs. Thompson, come in the morning and try and get that one. Do your best. We're going to go over it in class. Because tomorrow you're going to have time to work. You're going to have the worksheet that goes with this. But question number 28, I want you to notice it says, well, what variables will you use? What will they represent? How many inequalities do you need to write? And it says, is it possible? So if we're looking at these graphs. And in this one, number 29, does the system have any solutions? This gives people, because two inequalities, if I have one going like this and one like this, and this one's above and this one's over here, they're going to have nothing in common, right? Especially if the two lines are parallel. Is it possible to have no solution? So that's what they're kind of getting you to think of here, okay? And then you're just finishing it off with the through 33. So do your best. I'm going to give you time to work now.